Some of you who are very talented might try to measure the diameter like this. Yes, this is a much better way than this, I guess. We can try to measure the diameter like this, but again, the diameter of the bottle is not exactly on the millimeter scale, it is falling somewhere between the inch scale and the centimeter scale. And again, I have to make an estimate, and again, there will be some parallax error. Hello student, in this video I will talk about estimating the uncertainty in a particular physical measurement. I find that students are often confused regarding this measurement of uncertainty, estimation of uncertainty. So, I thought that it is apt to make a small video on this. So, what am I actually talking about? In any physical measurement, there is always some amount of uncertainty. Measurement is always expressed as measured value, or you can say the best estimated value. In place of measured value, you can write it as best estimate plus some uncertainty. When I make a measurement, I am never sure that my measurement is absolutely correct. The exact length of this object is only known to the God. So, whichever instrument I am using to measure the length, there is always some amount of uncertainty built into it, and my reported value of measurement can never be perfect. So, I always say that my measured value is my best estimate. Best estimate can be taken as the true value, because God is not going to give us a phone call to actually tell what is the actual length of this object. So, best estimate plus I will always mention the uncertainty, because I am not never 100% sure that the estimate that I have made is exactly correct. So, the uncertainty of a single measurement is limited by the precision and accuracy of measuring instrument along with many other factors. Here, I find that students are often confused. If I am measuring a length using this scale has a least count of 1 millimeter. This is a normal scale that everybody has in his geometry box. So, this scale has a least count of 1 millimeter. I hope all of you have seen this kind of scale. The smallest division here is of 1 millimeter, and the least count of this scale is 1 millimeter. But does it mean that when I measure a length, the uncertainty will always be limited to 1 millimeter? Is it mean that whichever length I am measuring, the uncertainty will be always 1 millimeter? The answer is no. Let me tell you why. Suppose this is a water bottle, okay, and you ask me to measure the diameter of this water bottle using this scale. So, what am I going to do? I am going to place this scale like this, and I will try to measure the diameter. Is there any other way? Well, you can keep thinking, but the point is, if I am measuring the diameter like this, there is a great chance of parallax error, and I can never be sure that my uncertainty is only limited to 1 millimeter. In fact, in this particular case, I think that uncertainty in my measurement of diameter can be as high as 5 millimeter, half a centimeter. So, who will decide the uncertainty? It is the experimenter who is the best judge of the uncertainty involved. So, the uncertainty that we write in measurement is also uncertain. Yes, the uncertainty that we write in the measurement is also not a sure thing. There is a guess involved in that. Some of you who are very talented might try to measure the diameter like this. Yes, this is a much better way than this, I guess. We can try to measure the diameter like this, but again, the diameter of the bottle is not exactly on the millimeter scale, it is falling somewhere between the inch scale and the centimeter scale, and again I have to make an estimate, and again there will be some parallax error. So, if I have been asked to measure the diameter of this bottle using this scale, the best I can say is that there will be an uncertainty of 5 millimeter, half a centimeter. Some of you may be very smart and you can devise ways to lower down the uncertainty, but still I guess it will always be higher than 1 millimeter. It is not exactly equal to least count of the instrument, isn't it? Now, suppose I use this vernier to measure the diameter of this bottle. This vernier has a least count of 1/10 of a millimeter, 0.1 millimeter. Now, I am trying to measure the diameter of this bottle using this vernier scale. So, my uncertainty will be limited to 0.1 millimeter. No, not at all. This is a flexible bottle. This is a flexible bottle, and if I apply a small pressure, the diameter reduces. So, when I put it here and try to tighten it, I am not sure how much tight it should be actually. I am not sure. If I loosen it a bit, I feel that no, there is a gap. If I tighten it a bit more, I think that it has been compressed. So, its diameter has been decreased because it is a flexible bottle. So, again I am not very sure that the uncertainty is only limited to 1/10 of a millimeter. In this particular case, if I am very smart and doing the measurement very carefully, I may say that the uncertainty will be somewhere around a millimeter or 2, but I can never be sure that it is only 0.1 millimeter. So, the amount of uncertainty that is there in a measurement is itself an uncertain thing, and the experimenter is the best judge of the amount of uncertainty in a particular measurement. So, this is what I have written here. Unfortunately, there is no general rule for determining the uncertainty in all measurements. The experimenter is the one who can best evaluate and quantify the uncertainty in a particular measurement. So, I hope all of you do understand now that uncertainty is also uncertain, isn't it? Okay. So, it is experimenter who will decide the uncertainty. It is not only the least count of instrument which will fix the uncertainty, but do not get confused. If a question says that length of this pen is being measured using a scale of least count 1 millimeter, okay, you can take the uncertainty to be 1 millimeter, assuming that no other experimental constraint was there, experiment has been carried out in a beautiful manner and the uncertainty is 1 millimeter only, if that is the only information available to us. Now, if there are multiple measurements, we often make multiple measurements. Like if I am trying to measure the diameter of this bottle, I will take multiple readings and then take the average, right. So, when we take multiple measurements, how do we estimate the uncertainty? When there are 5 or 10 measurements for finding the diameter of this bottle, what will be the ultimate uncertainty that I am going to quote? So, let us learn a little bit about that. Let us say here I have said that there is a rod and the diameter of the rod has been measured using some measuring scale, and these are observation numbers. 10 observations have been taken. First observation, which I have written as x1, is 2.43 centimeter, second observation is 2.42 centimeter, and so on and so forth. Overall, there are 10 observations, right. Now, first thing that we do is we take the average of all these observations. We just take the average of all these observations. That means you have to add all these x1, x2, x3, x4 up to x10 and divide it by 10. If for this particular example, if you do the averaging, if you find the average value of x, you get 2.42 centimeter. So, if you ask me what is the diameter of this particular rod, I will let this be that rod. So, I will say that to the best of my knowledge, diameter of this rod is 2.42 centimeter. To the best of my knowledge, the diameter of the rod is 2.42 centimeter. This is the true value for all of us. But if you keep a gun on my head and ask me, are you very confident about this number? Then I will get a little bit shaky and I will say that no, this is my best estimate, but I am not very confident that this is the diameter of the rod. There could be some uncertainty in my answer, my measurement. The diameter is 2.42 centimeter. This statement has some uncertainty, right. But the best estimate according to me is 2.42 centimeter. But there is some uncertainty in that. What is that uncertainty? Now, you ask me, how much uncertainty is there? You are saying that diameter is 2.42 centimeter, but how much uncertainty is there in this measurement? Please quantify that uncertainty, and this is what I am trying to tell you, how to find that uncertainty. One simple way is finding the average deviation. So this is how we do it. This is the same table. Observation number, recorded diameter 2.43, 2.42, 2.40. Average of all these is 2.42. So what we do is, we record the deviation in the first reading with respect to the average. Average is 2.42. We take it as true value. There is no other way of knowing the true value. God is not going to give us a phone call. So we will assume that 2.42 is our true value. So how much this particular measurement is deviating from 2.42, from true value? So obviously 2.43 minus 2.42, that is 0.01. We will always take the mod of that, forget about plus minus sign. Similarly, what is deviation here? 2.42 minus true value, that is 2.42, is 0. 2.40 minus 2.42 is minus 0.02, but take mod of that, it is 0.02. So for each individual reading, we will find the deviation from the average value, deviation from the mean. So all these are deviations from the mean. Now we will take the average of all these deviations. हर individual reading में deviation लिया, and now we will take the average of all those deviations in this particular expression. X1 is reading number 1, X bar is the mean value, that is 2.42. So take the difference, take the mod, go on doing like this for all the observations, and add all these deviations, divide by the total number of observations. If I do it here, the first deviation is 0.01, the other is 0.00, another one is 0.02. I have added them all and divided by 10, I get about 0.01 centimeter. So this is the mean deviation. So one way of expressing my measurement will be that I will say that diameter, to the best of my knowledge, is 2.42 centimeter, but there is an uncertainty, and the uncertainty is as large as 0.01 centimeter. So what I am saying is, my best estimate is 2.42 centimeter, but there is a but. There is an uncertainty of 0.01, which means diameter can be anywhere from 2.41 to 2.43 centimeter. So diameter of this rod is anywhere between 2.41 to 2.43 centimeter. Now, is this the best way of estimating the uncertainty? Am I 100% confident that diameter of this rod is somewhere between 2.41 to 2.43? If you again put a gun on my head and ask me, are you 100% confident that diameter of this rod is somewhere between 2.41 and 2.43? Again, I will get shaky. No, I will say no, I am not 100% confident. Then what is your confidence level? The answer is only 50%. I will say, I am 50% confident that the diameter of this rod lies in this range. Yes, you have heard it correctly. This uncertainty is also uncertain, and my confidence level regarding this uncertainty is only 50%. If you calculate the average uncertainty, average deviation from the mean, then this number can be regarded as uncertainty, but with only 50% confidence. So the actual thing is that the true length of this rod might be different from might be less than 2.41. It may be greater than 2.43 also. If I bring a very good vernier caliper and do one measurement, just take one reading, what is the chance that that reading will fall in this range? It is only 50%. It is only 50%. And 50% chance, 50% of the times, the reading may fall outside of this range, 2.41 to 2.43. What I am saying is, we bring a good vernier and do 5 or 10 measurements again, then there will be measurements which will be outside this range, and 50% of those measurements may lie in this range. So my uncertainty is also uncertain. I am only 50% confident about this. Is there any better way of expressing the uncertainty? Answer is yes. A standard deviation is a much better way of expressing the uncertainty. What is that standard deviation? Again, this is the same table. These are the observation 2.43, 2.42 and so on. These are deviations of individual reading from the mean value. Mean of all these is 2.42. 2.43 minus 2.42 is 0.01. So, this is the mean deviation, right? This is the mean deviation. I have not taken mod this time. I have included them with sign. This is minus, this is minus, this is minus. Okay. So, this is the mean deviation. Now, this column gives you the square of mean deviation. First calculate the mean deviation, then square them. Square 0.01. So, it is 0.0001. Square 0.02. So, it is 0.0004. So on and so forth. So, this is square of all mean deviations. This is square of all mean deviations. Now, the standard deviation is calculated using this formula from statistics. Sigma is a standard symbol for standard deviation. What is this? This is xi minus x bar whole square. This is xi minus x bar and this is square of that, right. This is square of all deviations. So, you have to calculate these squares and then add them. Sigma means add all the deviations is squared. This is deviation is squared. Now, you have to average that, right. So, deviation squared ko jod dijiye and then divide it by n minus 1, not by n, it is n minus 1. Actually, there is something known as degree of freedom, and in this particular case degree of freedom is not 10, it is 9 only. So, we divide by n minus 1, you just need to memorize this formula for a standard deviation. So, this is square of deviation in each individual reading added up, divided by n minus 1 and then take the square root of that. This quantity is known as a standard deviation. For this particular table, I did all the calculations and found it to be 0.02. So, this standard deviation is 0.02. Now, what does this standard deviation actually tell me? What does this standard deviation actually tell me? It is 0.02, right? What does it tell me? Now, again bring a very good vernier caliper and measure this diameter, let us say, good scale and measure this diameter. There is 68% chance, about 68% chance that the diameter will be between, this is the true value, average of all the values, and the standard deviation is sigma, that is we have calculated it as 0.02. So, now I can say that I am 68% confident that if you do a measurement, that measurement will fall in this range. What I am saying is, if you do a random measurement, the measurement will fall in this range. It will be somewhere between this number and this number. I am 68% confident about it. If you take twice of sigma as uncertainty, that means if I take 2.42 plus minus twice of sigma, that means 0.04, which means I am saying that 2.38 to 2.46. If you take this range, then I am 95% confident that the diameter of the pen lies somewhere here. If you take a random measurement, your measurement is going to lie in this range. I am 95% sure about that. Still, I am not 100% sure. I can never be 100% sure actually. So, I will only say that I am 95% sure that the diameter of the pen truly lies in this range. And if you take 3 sigma as the uncertainty rather than sigma or 2 sigma, if you take 3 times of that, that means in this case if you take it as 2.42 plus minus 0.06, then I can say that I am 99.7% confident. My confidence level is 99.7% that you take a measurement, random measurement of this diameter and it will fall in this range. Yes, I am 99.7% confident. That means if you make 100 measurements of the diameter, 99.7% of the, rather if you make 1000 measurements, let us say, if you make 1000 measurements of the diameter, then out of those 1000 measurements, 997 measurements will lie in this range. So, my confidence level is pretty high, but still it is not 100%. So, what I wanted you to learn is there is always some uncertainty in the uncertainty itself. Students, I hope you enjoyed this session. Goodbye. See you in the next session.